Good day, grade 11 students. Welcome to the HP Classroom. This video is all about proving divisibility statements using mathematical induction, wherein integer p is divisible by an integer q if p is equal to q times r for some integer r. So we need to prove that p is divisible by q for some integer r. So here are the steps in proving divisibility statements using mathematical induction. Just like solving summation identities, we need to verify that f of n is true for n is equal to 1 for the first step. For the second step, we need to do the hypothesis of induction, in which we assume that the statement is true for any value of n is equal to k. We need to assume that, and for assumption, we need to assume that the statement is true for n is equal to k plus 1. These first three examples are like the mathematical induction. However, for proof, we need to prove the statement using f of k plus 1 minus f of k. So the values that we will get from there. And we have added another step, which is divisibility test, in which we're using the values of we will get from step 4, and we will balance it out by adding f of k to both sides of the equation. And for the last part, conclusion, therefore, we need to conclude that f of n is divisible by a certain number for all positive integers. For the first example, we need to show that n cubed plus 3n squared minus 10n is divisible by 3 for all positive integer. So I put this in the form of a sub n equals n cubed plus 3n squared minus 10n. The first part of proving is always verification. So for the first part is verification. But this time, we do not need to prove until the third term. We just need to let n be equal to 1. So let's substitute it to the given function. Let's have f of n is equal to n cubed plus 3n squared minus 10n. Replace n with 1. So we have f of 1 is equal to 1 cubed plus 3 1 squared minus 10 times 1. So let's evaluate. 1 cubed is 1. 1 squared is 1 times 3 is 3. Negative 10 times 1 is negative 10. So our f of 1 is equal to negative 6. Wherein negative 6, as we all know, is divisible by 3. So I will just write it here. Negative 6 is divisible by 3. So the next step in proving divisibility statements is the hypothesis. So for hypothesis, we will let our n values become k. So let's copy the function and replace n with k. So we have f of k equals k cubed plus 3k squared minus 10k. So that's it for hypothesis. We assume that this is divisible by 3. For the third step, we need to have assumption, wherein assumption is letting n become k plus 1. we will change our function with the values of n is equal to k plus 1. So we have f of k plus 1 equals, let's enclose it with the parentheses, we have the cube of k plus 1 plus 3 times the squared of k plus 1 minus 10 times the binomial k plus 1. So that is for assumption. So we will need these values for our next step, which is proving. So we need to prove that this function is divisible by 3. Let's have the equation f of k plus 1 minus f of k. So for this example, let us copy the values that we have derived from the assumption minus the expression we have derived from the hypothesis. So let's start. We need to write this expression, the cube of k plus 1 plus 3 times the squared of k plus 2 minus 10 times k plus 1 minus k, the expression k cubed plus 3k squared minus 10k. So this is like the concept of telescoping sums. So let's expand this term. So we have k cubed plus 3k squared plus 3k plus 1. We need to multiply k plus 1 2 times by itself, so and multiply it by 3, so we have 3k squared. Okay, wait. So let's do this step by step. So let's expand the square root of k plus 1, and it becomes k squared plus 2k plus 1. Distribute negative 10 to the binomial. We have negative 10k minus 10. And distribute negative 1 to the trinomial. We have negative k cubed plus minus negative k squared, negative 3k squared plus 10k. Let's copy plus 3k plus 1, and then distribute 3 to the quadratic trinomial. So we have 3k squared plus 6k plus 3, and copy the rest of the terms. We have negative 10k minus 10 minus k cubed minus 3k squared plus 10k. In here, I have already cancelled out terms which is equal to 0, and then I'm left with these terms we need to add. So we only have one 3k squared, so I'm going to write it here. Then we will add like terms, like 3k plus 6k. So the sum is 9k. And then we have the constants. We're left with negative 6. So as you can see, we can factor out the common factor, which is 3. And we have k squared plus 3k minus 2. As we observe, the first factor is divisible by 3. So I will just write it here. So we need to factor out a common factor for this given terms, and we are left with 3, which is also divisible by 3. Our next step is to have divisibility test. For divisibility test, we will use the value of f of k plus 1 minus f of k. However, we need to balance it out by adding f of k to both sides of the equation. So we will just copy this answer, 3 times the trinomial k squared plus 3k minus 2, and then we will add the value that we have gotten from f of k. So that is the note there. We will add f of k to both sides and just substitute it to the given equation. So we have 3 times the trinomial k squared plus 3k minus 2. Then we will add this answer, which is k cubed plus 3k squared minus 10k. So we will not evaluate it anymore because it is simplified already. So our first factor is 3, which is divisible by 3. That's why we can already conclude for our sixth step that we need to conclude that n cubed plus 3n squared minus 10n is divisible by 3 for all positive integers, or all positive numbers. So that's it for the first example.